I would ask first the question, can you see the screen?
Yes.
Yeah.
Okay. If anybody wants to follow along and do their own clicking down at the bottom, because there's some hot links in here if you want to go investigate them. But you can go to that tinyurl.com/ whatever that thing down there says, and you can follow along with that. And ultimately, what I'm really going to talk a little bit about are some of the Astronomical League's current observing challenges. Right now, there are three of them going on. So anyway, uh, Dan talks about this a lot. I talk a lot about it too, and David Wood's done maybe some of it too. There right now is in the final stages of what they call the Hubble 35th anniversary challenge, and ultimately. The only part you can probably work on now, if you haven't done other parts, is the silver level of it. Sorry. And the idea is that what you do is every month you go out and you shoot one target out of a list, and then you do an outreach about the Hubble telescope and stuff like that. And you turn it in, and then you can get yourself a certificate. And this is obviously the month of September, and every month the targets are different. And so you can see over on the right-hand side there, hey, you got to image or sketch one of those 10 targets. And M15 is nice, and everybody likes M27.
You're still on
And,
the first
you know,
slide from what I see.
pardon?
Yeah, I'm not moving.
Okay.
Yeah, me neither.
You're still stuck on that first guy?
Yes.
Yep.
Interesting. I'm on a second guy. Let's try this a different way.
Oh, I bet you're sharing a different screen.
Okay, that could be. Stop sharing. Let's go share something different.
Steve Boerner.
Do you see Hubble 35th there?
You're not sharing anything on our end.
Tch. You really didn't want me to do this tonight, did you?
I could pull up that tiny URL and share it from here if you want me
If
to.
you want to do it, go ahead.
You can put on CC, closed caption.
Um,
Waiting for Esther Williams to come on at 8 o'clock. That guy in the middle was one of.
we see your Zoom screen now.
Yay, but you don't see me. Do you see Hubble 35th now?
It's
Yeah.
working now.
There you go.
Yay, finally. Sorry. I've been out to dinner and I haven't drank. Anyway, there are a list of the targets, and what you would do is one of them. And then you could also then do an outreach session and just talk about Hubble telescopes or the image that you have. And then truthfully, if you want to find more information on it, down at the bottom here, where you see that link, if you would click on that link, it will take you to the Astronomical League's webpage about it. And you got to scroll down to, I believe it's number 13. So apologize for the scroll there, but then you would find more information somewhere on this page. Anyway, we quit off that one. So anyway, back to that. The Astronomical League has a different challenge.
Fortunately, Steve, it's still on the NASA
Webpage.
Yeah.
Hey Dan, I think you're gonna go through these.
Yeah, what's tinyurl.com? What's the
Wait a minute. tinyurl.com/capital AL dash observe the moon 2025, and the you got dashes between those. The O in observes a capital, and the moon is M is a capital.
hold on, it's running at light speed.
Hmm?
It's opening the file, it's just real slow for some reason. Actually, I don't know what it's doing. It's saying opening in Google Slides, but that's all it's doing. Okay.
Yeah,
That better?
Yeah.
yeah.
So anyway, those are the things. And so that if you would go to that URL down there at the bottom. Oh, can you see my mouse pointer?
Yep.
Can't see yours.
Okay.
You can see mine probably.
We'll have dueling mouse pointers. That could be fun. So anyway, if you go to that URL, you can find out more information and what you would have to do if you wanted to submit that information. Can I have the next slide, please, Dan, sir? Okay, and so there are another challenge that's going on deals with the moon of Saturn called Titan, and Titan is in the right positions, and the ring tilt of Saturn is in the such position such that the shadow of Titan goes across the surface of Saturn, and it's called a shadow transit. And ultimately, these are kind of rare events. There are some that are going on so far this year. You may have heard about them. Two have happened so far. There is a third one that's going to be coming in. I'm going to say late Saturday night, late Friday night, beginning of Saturday. Then there's going to be another one a little bit later in the month and one in October. And then past that, I think the next ones will happen in the year 2040. Ultimately, there's going to be one this coming Saturday night. It's going to be from about
Midnight.
after midnight. Yeah, I like that. I was trying to how to say that time, 0.0042 a.m. to about 4 o'clock in the morning. And what you will see is a little bitty black dot that goes across Saturn. This one is going to be such that you're going to be able to also see Titan itself go across, and the shadow will be really, really close to it.
Wow.
The last one, the last two, the weather hasn't been particularly good. The first one that went on back in August, I think Jack was there, Andy was there. Oh, there was Bromleswick Park. Jack was there, Andy was there, I was there, Dan was there, Jim Twooman was there. I'm probably missing one or two other people. It was kind of interesting. It was kind of fun. It's something you don't see all the time. So anyway, you might want to think about doing that. Then
Hey,
in
Steve,
terms of yes, sir.
hey, Steve, as long
Yes, sir.
as I'm hoping that on Friday, this Friday coming up, that the C14 is in at least, decent condition, I'll be happy to make sure that that it's on Saturn, probably 11:30 or 11:45 for sure.
Okay. Okay.
And I've got a 2-inch diameter 2x Barlow and really, really good 9mm lens if we need it. So we should be able to get, if the atmosphere supports it, we should be able to get some pretty good views of Titan, I would think.
Okay. Now, I will tell you as a warning to everybody, I did check a couple of days ago and long range forecast did say thunderstorms Friday evening. So who knows?
Wow.
Anyway, there will be one more after this Saturday's, and that's going to be on October 4th. If you were to go to the Astronomical League's webpage, they will say this one wouldn't count to be able to do it for the actual challenge where you do the outreach, you draw the picture, you draw a picture, you take a picture or something like that and submit it. Okay. But really, I talked to Cliff Migert today, and Cliff did say that, hey, yeah, you can go ahead and count it. Just send it in to him and all would be well. Ultimately, this one is in the evening. It's really a kind of a nice time. It's going to be between about 8:30 and about 11, about midnight. And so it's a nice time. You're not going to lose a whole lot of sleep like we did last time. So that's pretty cool. Would Dan like to do the next slide? And another challenge, and this is the one I really, really promised about. Every year, and you can read these slides and I'll babble through them. Every year, the NASA gets together and they sponsor something that's called International Moon Night. And they actually try to sell it to other countries and they try to sell it to clubs and that sort of thing, such that they would offer like outreach sessions, kind of like a Friday night open house. Okay. And talk about the moon and why the moon is important and it's fun to see the moon. As imagers, a lot of times we kind of think the moon is a bad or an evil thing. But truthfully, if on this International Observe the Moon Night, you could actually go to a Walmart parking lot and do the thing from there. Generally, it's on a Saturday night. Generally, it's in late September and early October. Generally, what you do is that you just get out there and you tell the people the moon is cool. And there's a sneaky reason why NASA does that. And if you look at that URL, if you're following along or if you download this thing later on, if you click that, it would take you to the International Observe the Moon Night thing that's on the NASA's actual site. Dan, you want to hit me with the next picture or next slide? If you go to that page, ultimately, I stole those two paragraphs. It kind of gives you a reason why NASA is interested in doing it. It tells you what you're supposed to do. The second paragraph is actually asking for people to host star parties, except they're not star parties, they're moon parties. And then down at the bottom, there are three URLs. That middle URL actually will take you to a page where you can register and say, hey, look, I'm a member of this club and I'd like to sponsor this event. And it'll let people know to show up on that particular night to do your thing. I say club. You don't have to be a club to do it. You could do it as a person or that sort of stuff. So that's a pretty cool thing to do too. You want to hit me that one? Oh, sorry, wrong direction. And go to the next slide. Okay. Now, ultimately, there are reasons why NASA does it, and one of the reasons they do it is this one where it says raise awareness of NASA's lunar science and exploration programs. They really do want the public to know that they're trying to spend the money wisely. So they want people to look at the moon and understand why it's an important thing to do. And so those are reasons why. And then, truthfully, for us imagers, the reason to do it is, again, it gives you an opportunity to go on a night where you would not normally be out, not necessarily a night where there's a dark sky from a dark sky location. Like I said, a Walmart parking lot would work for this guy. You want to hit me with the next slide? Okay. Ultimately, NASA does the International Moon Night, but the Astronomical League pretty much always has a challenge that's associated with it. Ultimately, it's usually a bigger window than just that October 4th night. And so ultimately, this year it's going to be between October 2nd and October 11th. And there's a reason why October 2nd to October 11th, and you'll understand that when you see the list of targets that you have to do. In that window, there are two Friday nights, and so it would be good for Friday night open houses. That would work pretty well. And ultimately, if you're an AL member, you can do the challenge, but you don't have to be an AL member. So technically, anybody who would be at a Friday night open house at Bromelsick, if they would have a picture of the moon or if they wanted to sketch the moon and label the targets they have to label, they would qualify for that. Ultimately, if you do it, what do you get? Well, you get two things. First, you get a certificate, and little picture you see down there in the corner is the certificate that I got for one that was done a couple of years ago. It'll come to you as a PDF. And the other thing that happens is even if you're not a member of the Astronomical League, everybody gets their name posted on the Astronomical League's webpage in their database. And so ultimately, in 20 years, somebody can look back and go to the Astronomical League webpage and say, hey, look, there's my name. So, that's kind of a nice kind of deal. Would Dan like to do the next slide? Ultimately, when you do it, pretty much every year for these kind of things, there are 10 targets. Last year's targets all had to be done visually, naked eye kinds of stuff. This year, it's going to be a telescope or an image or binoculars. And here are the 10 targets. And so ultimately, you've got Mare Serentis and Mare Tranquillus and Imbrium and then Cognitum, and I can't pronounce those guys, plus a whole bunch of Apollo sites. Those are all the Apollo sites that are on the moon. You can find a little bit more about that stuff, once again, by going to that URL. Now, if you would go to the next slide, I have a picture. And so this is a picture that I took last month. And I said, okay, now where are those targets? And so you can see bingo and bingo and bingo. And so you would either sketch a picture of the moon, okay, or take a picture and then you label those targets. Now, this is done kind of with a SeeStar. Okay, SeeStars don't have great, what would be a good word? Don't have small field of views. And so this is a larger field of view, and I've labeled them that way. If you wanted to, and you want to do it with a different scope and camera, you could get actually close-ups of a number of those targets, the Apollo stars particularly. How do you find them on your own if you wanted to do this? Well, if you're a moon observer, one of the cool things is Virtual Moon Atlas. If you don't have Virtual Moon Atlas, you should download it. It is a free program. It lists literally 8 or 9,000 things on the moon, not just craters, but domes and mountain chains and just all sorts of stuff. So it's cool. If you have the program Sky Safari, if you have the app Sky Safari on your tablet or a phone, it will label what these are, and then you can find it from there. There is a picture on the Astronomical League's webpage of all these things and where they are, but it was taken under full moon conditions, and it looks really bad. Or you could cheat and just use my picture and say, hey, look, hey, where did Boerner put the arrow? Oh, there it is. I'll put the arrow on mine. So whatever, there we go. Want to hit the next one? Now, when you're done and you got it labeled, you got to turn it in. And ultimately over here, it tells you all the stuff, It says mailing address, but the truth is it's going to be an electronic certificate. So probably your email address is going to work just fine. Your astronomy club, or your affiliation, or if you're not in anything, just say, I'm not a member or anything, and that's going to be fine. And the sketches and what equipment you use and dates and times. And I will tell you that when I submit this, and I suspect when Dan does it too, mine is going to look something kind of like what you see in that picture, plus whatever information that I didn't include there. So, it really doesn't take a whole long time to do. Oh, and by the way, yes, I did take that with a Dwarf 3 and not a SeeStar. Want to hit me with the next picture? Now, the truth is, Club has what, 2 SeeStars? A number of other people have SeeStars. I know that Tan's got something, and that sort of thing. So the deal is, usually it's easy to image things with a SeeStar. Turns out the moon is not quite as easy. And by the way, that picture you see there is about how well the moon does fill up a SeeStar image. Normally, when you're using a SeeStar, you just go to the atlas and you pick your item, that you want to do, and then you click on it, and it'll do a flight solve, and it'll center the thing. Okay, and truthfully, you can even do that with a plan. The problem is if you go ahead and hit the next thing, doing it with the sun or the moon, they're a little bit tricky to find out for targets. Okay, a SeeStar kind of knows what the directions are, north, south, east, and west, and it uses an internal magnetometer to do that. Okay. But the magnetometer doesn't always work, and it kind of depends on where you plunk the SeeStar as to how well it's going to work. If you're doing something like the sun, there's some tricks. One way you can find the sun is if you use the solar filters included, there's this little bitty hole. If you put that filter over here and you have that little hole straight up, and then you use the joystick as you move the SeeStar left and right in azimuth, that hole will let light through and it'll shine a beam of light. And depending upon how it's all aligned, the beam of light could be orientated in this kind of direction, or it could be orientated in that kind of direction. And ultimately, what you want to try to do is get it so it goes right down the middle, and that will help you find the sun. Another thing they can do is between the base unit and the optical part, there's a crack. And as you turn it back and forth, you can get it such that as you look down here on the floor of the room that I'm currently sitting in, you see this little spike of light. If you do this outside, if you move it left and right and you get that spike, you're aligned with the sun. So both of those work for the sun, but the moon isn't bright. So can I have the next picture? So what are you going to do to find the moon? Well, like I said, if you're lucky, you can use the finder. Excuse me, the Atlas part of the finder, the software to find it, but it doesn't always work. And so what you need to do is you may have to reset the magnetometer, okay? And that you would do under advanced configuration. And to do that, you select, calibrate it. And to do that, you spin it around in a circle for about a minute. And I want to say, if it was Jack, I think Jack maybe said the way you do it is you don't spin the tripod with the SeeStar, you spin yourself and you go around in a circle. Well, anyway, somebody showed me that one, and it is a lot easier to do that, to calibrate it. You could try to do a go-to after you do a go-to on something else, like pick a bright star in the neighborhood, and maybe that'll help. I've never had too much luck doing that because the first thing it always tries to do is that first way anyway, and it's a pain. You can try to do a manual find, but the field of view is kind of hard, so that's a pain. And so ultimately, I thought, well, what else could I do? I took some rubber bands and I put rubber bands around mine, and I put a laser pointer underneath it. Okay, it wasn't Jack, but I don't remember who said it was, but it worked. But anyway, I tried it with the moon, and the truth is, it was too bright in my neighborhood, and maybe it wasn't humid enough, but the laser beam just didn't show up. And so finally, I said, "Oh, the heck with it," and I ended up putting a red dot finder. And this is a red dot finder here, and the red dot finder does work really, really, really well to be able to manually center the thing. Now, somebody's going to say, "Oh, well, that's great, but how did he get that red dot finder on there?" If Dan would hit the next slide. You can go buy these on Amazon for 25 bucks. And this press fits into the SeeStar's lens. Okay. And this guy rides on the top of the SeeStar. And then that's just like a regular old dovetail, a sinted dovetail. And so you just get a laser pointer on a sinted dovetail, and it works really, really, really well. It's 3D printed, it's plastic, it's 25 bucks, and it is ABS. And I mentioned ABS because if it were plate PLA, it might melt in your car in a hot summer or something like that.
Yeah.
Let's see. Once you find the moon, you can shoot individual frames. Or truthfully, for this challenge, you just have to take one. But if you can't want to, you can take individual frames, okay? Or you can shoot a video, or you can shoot a time lapse. And truthfully, time lapse I don't think would be too helpful here. But truthfully, the SeeStar does track pretty well. So if you ever want to try to do a lunar eclipse, you could do a SeeStar, time lapse where you say take a picture every 20 seconds and then take 800 pictures, and then it would be however long that would do, and it would run for you the whole time. Um, Ultimately, I think for doing this particular challenge, maybe a video would be good, and maybe shoot about a minute of video. Now, a truth is, so you got the video or you got the individual frames, what are you going to do with them? Well, a SeeStar does have the ability to stack those. Okay, you don't have to actually take the images off the SeeStar. You can just tell SeeStar, do it, and it will. And besides that, in the operation, they give you a way to sharpen it, which really, really helps. And you can adjust the brightness and you can adjust the contrast. So it makes the final image look really, really well. Now, there is a downside. And the one downside is that it does consume the SeeStar as you're doing it. By that, I mean, if you take 5 minutes of video and you try to stack 5 minutes of video, it might take 20 minutes to be able to stack that into a final picture, making use of I'll say the Raspberry Pi kind of thing that's inside the SeeStar. And that means you can't use it for anything else while that's going on. So that's the only downside there. If you like that idea, there is a lady who I have corresponded with. She's in Utah somewhere. She's a nice soul. She's kind of in a way an astronomy beginner, but she's got a video. Unfortunately, it doesn't have sound. She shows you how to be able to do this whole process of doing the capture, setting it up, and then using the SeeStar to stack the information. If you don't want to do the SeeStar, obviously you can pull those files off and you can use something like Registack or something like that. Oh, yeah, and AutoStacker.
Oh.
I do believe that the videos that a SeeStar takes need to have a different codec, and so you might have to do the PIP kind of thing too. There you go. Can I have the next slide? The SeeStar does have the ability when you're doing the moon and the sun to do it at different zoom levels. They are digital zoom levels. Okay. And so digital doesn't mean it gets better. It just means it just looks more magnified and more blocky, but it does do that. I would rather not do it. The truth is, particularly on the moon, you sometimes need a bigger moon to be able to find out where you are on the moon. I don't know if that makes any sense, but I can remember one time years and years and years ago, we were using the old C14 and trying to do some imaging. And the only way we could find where we were on the moon was take like I think it was a National Geographic lunar map and spread the thing out. It was probably 4 foot by 3 foot. And we tried to find out where we were on the moon. And the field of view was so small, it was just a nightmare to do that. It's nicer to have a bigger moon image to be able to see.
Flag.
Flag. Jesus.
How about the next slide? We're getting closer to being done. The SeeStar does have the ability, sorta, to shoot or 2K, 4K. The 4K is not real 4K. It's fake 4K. It's software based. It kind of does a drizzle. It'll slow things down a little bit. You should get just a little bit better resolution, but it's not going to be markedly so as if you're shooting real 4K. Could I have the next slide, which might be the last one? Ultimately, that video that the college lady made, and this is an image that I took, whatever word you want to use, off her video, and it shows you the resolution that you can get out of a SeeStar. And ultimately, looking at that picture, it got me thinking. Ultimately, you should be able to use a SeeStar to do some reasonable work, in terms of the moon. The Astronomical League does have 3 lunar programs. It's got the lunar program where you do 100 things. The bigger, the brighter kind of ones like that. They have a Lunar 2 program. In the Lunar 2 program, there's some smaller things. There's particularly some objects you're going to do that are around the edge of the moon. And ultimately, timing becomes critical. The moon wobbles, it vibrates, if that's the right word. It's libration's the right word. But it bounces back and forth. So you can't always get some of those edge features at the right phase of the moon to be able to do them. So you have to wait for those. And then third one is called lunar evolution. Lunar evolution is kind of cool. And what you do with that is you image craters like that crater right there. And you would say, oh, look, that's got a really nice sharp crater. I bet you that's a relatively recent kind of thing. Versus if you look at this big old crater right here, that guy right there looks, that's craters. It doesn't have, it's not sharp. It looks like it's kind of filled in a lot. So I bet you it's really old. And you try to do that with, I think if it's 50 maybe of the features on the moon. And it's kind of a logic kind of puzzle. I thought that was rather kind of interesting. So anyway, I think that might have been the last slide. Is it?
It is.
Dan said it is. So I'm done. So anybody need to know anything about any of those observing programs? Anything about a SeeStar? Anything about the college lady? Oh, I should explain and say she taught at some university like lab classes and that sort of stuff. And I did that kind of stuff long ago, last century too.
Steve, I did watch some of those videos by the women you referenced, and she also did some where the SeeStar would follow some of the birds out in the distance. And yeah, so I thought they were put together very well. I thought she has some nice material.
She's a nice lady. I'll just say that.
I haven't opened my SeeStar in 3 or 4 months. I'm hoping I remember what to do. Once I got all the equipment to do the equatorial, the skies were just, when I could get out to see stuff, it was just so bad, and just thought, oh my goodness.
Okay. I would make the typical kind of comment that if you haven't touched it in 3 or 4 months, make sure you set it up and try it in your backyard before you put it in the car and drive a quarter of the way across the state.
Yeah.
Yeah, I found that out last Tuesday. I got my SeeStar out and I didn't set it up beforehand, and I get to the site and it wants to do an update.
Oh yeah, that could be a problem. Yeah.
That's what I
Yeah,
meant.
I've got a battery pack for it too. So like a 3,500 amp hour,
They'll run all night.
But milliamp hour. Yeah. Yeah. In case they run out, I could plug it into that thing. So at least I'm thinking a little bit ahead, but yeah, I'll try it out in the backyard. Just these dang street lights. So.
Well, I would point out, okay, that today officially I am number 28 with the Imaging Messier program, and I did it completely with smart telescopes. I did most of the objects with my SeeStar. I do have a Dwarf Lab kind of thing. I had a Dwarf Lab too, and I used it for the bigger ones. But I used the SeeStar for pretty much everything. The Virgo cluster I did from dark skies in Kentucky, just because I was in Kentucky with my son and grandson. But pretty much everything else I either did here at my house or Chesterfield Mall as they were tearing it down, or Saks Library that's 100 yards, a couple hundred yards away from Chesterfield Mall. And
So if you,
ultimately, I was really happy with the stuff.
so if you've done an observational program from SEA, you can still do the photographic as well.
You can do them both. You will get two certificates, but only one pin.
Yes, yes, yes. Cool. So how did it turn out the Virgo cluster? Were you able to actually make out because of the size? Did you get some good photographs?
Yeah, I think everything was believable, you know. And the truth is, what I ended up doing, and if you've seen the college lady's video,
Yeah.
you know how she's got the SeeStar image, but then she'll zoom in. Okay, what I did on the log that I submitted is I had the original SeeStar image, but then and how I would do it, I would zoom in on the object so it would make it a whole lot bigger.
Oh, okay. Yeah.
I'm thinking about getting one of those sea stars. I see a trip to Chile in my future, although I need to get my passport up to date. I'm thinking I can't take my telescope and carry it on, but maybe a sea star would be something I could pull off.
Mhm.
That seem feasible, or is it really unwieldy for something like that?
Oh no, it would be wonderful.
Cool.
I think some of those newer, if you want to go more advanced than that, a lot of those newer small, I forgot the term escapes me. The newer ZWO type mounts are really light and small, don't require counterweights and stuff like that too.
Yeah,
The
I got
AM3 or the AM5.
Yeah,
AM5.
yeah, I can't think of the name for those strain wave mounts.
Yes.
There's about 10 or 15 different people making them now, and those even those little ones are small enough that you can put in, they're the size of an old camera bag or something.
Right. That's a good point. So I could bring the AM5 and my Nikon and
Yeah, or even a small short refractor or something if you had something like that.
right.
It might be able to fit in a carry-on.
Are those more active than an equatorial?
They're just the newer style. They are equatorial. They're
Okay.
just new style, so to speak. Um,
I've been really impressed with my AM5N.
yeah, so you know what I'm talking about. Yeah.
Yeah. That's a good point. I'm just thinking I got to do the entire setup now. Now the cat shows up.
And I mean, and that's the advantage of a SeeStar in the sense it is turnkey. The
Yeah.
only thing you need to do is open a box, screw in the tripod, spread the legs, and plop it down and press the power button.
Yeah.
Apparently, my cat wants to know how Grant's cat's doing.
Now
He saw
Yeah.
Grant join. So
you gone and done it. Now you gone and done it.
Holy cats.
we'll be hearing meows soon enough, huh?
It was quiet while the night lasted.
Okay, thanks.
I won't say the FOOD word.
Oh, yeah. Oh, maybe I should.
oh.
Poor kitty cats.
Really?
Boy.
I think, Steve. Jack, did you still want to present tonight?
Sure. Me and Mr. Darcy will be glad to. Let me hit share.
and hopefully it works better than me.
Yeah, it's weird. We have your background, just not you. Like it thinks you're part of the surrounding.
Okay, if I did this right, you should see solar powered astronomy.
Yes.
All right, good. All right, so today we're going to talk about solar powered astronomy, and it's not just using solar panels to keep your telescope going, because that would be kind of stupid. But we are gathering photons so that you can gather photons. So when you go out to do astronomy, obviously the remoter the better. Access to power can be difficult or limited. And so your choices are, you could use a generator running on fossil fuel. Of course, that's eco-unfriendly, but even if you disregard that, there's the noise and the smell of running generator. You could use wind power, but that's hit or miss. And actually, if it's really windy, it's probably going to stink for astronomy, although I guess you could have daytime winds that calm down in the evening. So I went down the avenue of solar. There's pluses and minuses. Oops, sorry. It's clean. By the way, can you hear me okay? I didn't
Yes.
do an audio check. Okay. It's clean. It's free. Well, of course, after an initial purchase. It's lightweight. It's relatively consistent. There's no fossil fuel involved and allows very remote use. It does require planning. You can't just, oh, it's 5 minutes till sunset, I better do my solar stuff. And you've got the restriction of clouds and trees that can be a factor there. And you could come up short when all's said and done, depending upon how the day goes. Here are the basic elements of a solar system. Number one at the top, you got the solar panel, and it's feeding into number two in the middle there, a charge controller. The charge controller gives some power into the battery, number three off to the right, and that provides the DC load coming out of it. You can have number four off to the left, a UPS or inverter to provide an AC load output. For astronomy, many systems can run on DC only, and in fact, my system runs completely on DC. So that part was not needed. And down at the bottom, you got green power to your home. Of course, that nobody puts green power to your home. You put it to your telescope. So the steps involved, you got to determine what your needs and wants are. You got to weigh that against your budget. You got to purchase it, assemble it, and test. You don't want to find out when you're out there that, oh, I forgot one thing, and you're in the middle of nowhere, and you're up the creek. So as part of determining your needs and wants, I broke it down into astronomy and personal needs. Needs and wants, I should say. I guess none of this is needs, all of it's wants, right? But for me, I had my mount, which was ZWO AM5N, my camera, which was in ZWO ASI 294MC. My guide camera was a ZW. Did you see a trend, by the way? My guide camera was ASI 120mm, and my computer was ASAir Plus. So if it wasn't red, it wasn't attached to my telescope. For personal needs, I had my SLR camera, I had my cell phone, and I had a supplemental battery for my cell phone. I have one of those little gadgets that you stick onto your phone to give it a little extra gas when the phone battery got a little lower. I had Apple Watch, an iPad, I had an emergency radio, I had flashlights, and my CPAP machine. I don't know if you're familiar, for people that snore a lot and have health problems with their sleep apnea, you need the CPAP machine. So here comes the math part of the show. You have to calculate what your batteries are. So on the needs side of things, I calculated by my specs. My AM5N is 12 volts and uses 0.4 amps on standby, 0.7 amps when it's tracking, and 1.7 amps when it's under heavy load mode. So I took the worst of the bunch, the 1.7 amps, multiplied that times 4 hours, assuming a 4-hour observing session, and I came up with 6.8 ampere hours. While you're at it, you might want to allow for tag-alongs. Hey, I need to charge my cell phone. Could I borrow some of your power to help me get a phone call to my wife? Yes, sure, fine. So I multiplied times the fudge factor and came up, in this case, I multiplied times 2 and then rounded up to the nearest ampere hours that were available for a battery and bought that battery. In my case, I went ahead with 2 batteries, one for the mount, one for the ASR camera. I had heard somebody say once that you're better off having independent power supplies for your mount versus your ASR. I don't know if there's any truth to that rumor, but I've had good luck with my setup. There may be some guesswork. That's what I did for my ASR battery. I just guessed and came up with 12 ampere hours. I figured it would be pretty significantly less than the what I needed for the mount, and then gave it a little bit of wiggle room there. On the personal side, I had my CPAP machine and my laptop. I recommend strongly to get a DC cord for your device if possible. There's a lot of inefficiency to go from a battery to an inverter and then back to an adapter that's built into your system to go ahead and power something that's going to be powered on DC anyway. So I was able to find DC cords for both, and I practiced on some other batteries, and they determined that for that personal use, 15 ampere hours would be enough. So you can see I got an 18 amp, a 12 ampere hour, and a 15 ampere hour battery from my calculations. So now that you've got that all figured out, you got to figure out what your solar panel is that's going to need to power all these things. So your amps is going to be your ampere hours divided by your hours in the sun. So you got 12 ampere hours, 18 ampere hours, 15 ampere hours. You add all those up, and then you divide them by the number of hours you think you'll get in an average daytime. So I just guessed we'd have 7 hours of daylight. Of course, if you're going out to observe in the dead of winter, that's probably, be a little bit less than that. But anyway, I came up with 6.43 amps, and watts is volts times amps. So 6.43 times 12 volts comes up to 77.16 watts. Don't assume that the manufacturer's specs, you're going to be able to get 100% of that. So I went ahead and came up, kind of rounded up, so to speak, and said, okay, let's pretend that 77 watts is 92 watts. And of course, they don't sell a 92 watt solar panel. So I got a 100 watt foldable panel from Renogy. That cost me $122. And the solar panel by itself is just the first piece of that little picture I showed you earlier. You need a charge controller for it. So, and some solar panels have charge controllers built into them. But this one I went ahead and got one that's separate. I went way higher than I needed to, 30 amps, but it's kind of a play it safe kind of deal. This model had some neat features in it. I also went ahead and got the Bluetooth module for this. It's kind of this is on the nice to have side of things, but I have to say it's kind of nice to be sitting inside an air conditioned vehicle and checking out what's going on with your solar charging. Oh, we're up to so many ampere hours so far, and so forth. So
wait.
I'm sorry. Somebody had a question.
I'll catch you in the end. I didn't realize my mic was on. Sorry.
That's okay. Anyway, so I got the Bluetooth module. I also bought their little wire kit, which was outrageously priced, but it's got the little connectors that they have, so it's kind of nice for what you're going to do. I also bought one of their fuses. Just want to have plenty of safety going on there. So that was the cost on the solar side. On the battery side, I bought 2 batteries from Bass Pro. I got the lithium iron ones. They're so much lighter than the old gel cells. So if you haven't tried those out yet, definitely need to check them out. go into Bass Pro, you're paying top dollar. I actually got a larger 30 ampere hour battery from Amazon for $63. So for less than half the price, I got twice the amount of ampere hours. So learn your lesson from me. The supplier I got was, oops, I just hit the wrong button. Where did I? Oh, sorry. Do you guys still see the presentation? No, probably not.
So,
Yeah.
Okay, let me stop and start. Sorry about that. I shouldn't have.
Well, while you're doing that, what are the dimensions on those batteries? Just typical.
That's a good question. I'll show you in a later slide.
Oh, okay.
Let me see.
Those are super, super light.
Okay, good.
Okay, do you see the presentation again?
Yeah.
Okay, I was right there and I didn't realize it. Yeah, we'll show you what they look like here in just a minute. But anyway, so for my total cost, it came up to 476. Obviously, some of these are optional. Your needs may be significantly less. Hopefully, none of you have to deal with a CPAP machine. So, and maybe you can come up with your own wiring kit and things like that. So, all right. So, once you've got all this stuff arrived in 700 different Amazon truck visits to your house, hook it all up. I recommend testing several times. With this particular system, you have to connect the charge controller to the battery first. So if you look in the bottom right, you'll see a little black box with let's see if I can zoom in. No, I can't. I went back to the doggone slide. I should have just stayed there. Anyway, if you look in the bottom right, you'll see a little black box and then a kind of a lime green thing. The lime green thing is the battery itself. It's about, I don't know, 5-6 inches long, 2 inches wide, 3 inches tall. So not super big, not too super small. That's my medium-sized battery. But in this system, you have to hook up the battery first. Don't hook up the solar first. And then I also recommend keeping the battery and the charge controller in the shade. And we'll see. Obviously, you got things sitting out in the sun; they'll warm up pretty quickly. Once you're all hooked up with that, you can go ahead and hook up your solar panel, and then you're starting your charging process. On the display on the controller, you can see the what it says PV volts. So this is the amount of power coming from your photovoltaic system. That's the solar panel itself. And you can see some dust on there. This is dust from Colorado from when I went to the Rocky Mountain Star Fair. Because I got the Bluetooth option on mine, it has an app that you can connect to it. It's the Renogy app. I think there's actually multiple apps, so I have not tried any others besides the one that I showed the icon over on the left hand side. It is available for iPhone and Android. On the first screen, you see, hey, okay, it says it's charging 53 watts, and then at the bottom, you can see I've given my system the name JGRNG Control ADV30. I don't know. I think I just stuck my initials on the front of it, but you can change it to whatever name you want. You want to call it, Poughkeepsie. That's fine. But if you tap on the bottom blue part of there, you can see the next screen, which tells you, what all is going on at this time. It shows a picture of the solar panel, and it's a little animated thing showing the juice going into the controller and into your battery. at this particular time, it was in boost mode. It's estimated the state of charge is 100%, but I think that's just 100% guesswork. Anyway, it tells you how many volts you got on the solar side, how many amps you've got on the solar side, and so forth. And I kind of, it's a longer screen, so I went in and split it and put it over to the right there. But you can see what the battery stats are as well. If you hit the little dots on the top right, you can see the settings, the history, and parameters info. On the settings side of things, my battery, I took a picture of the side of my battery. If you notice, it says charge voltage 14.4, maximum 14.6. You can set what the maximum boost volts is inside the application, so you don't have to worry about overvolting your equipment or your battery. I think Bill had talked about his trip to Rocky Mountain Star Stare. He had overvoltaged his Celestron mount and had to do some gyrations to get that thing back up. So be sure and read up on the specs on these. These are not your regular. That's the one thing about the lithium iron batteries, is that they run a little bit hotter than your regular old lead acid battery for your car. So check what the specs are on your system. You can also tap on the history, and I'm kind of going to whip through these because obviously your system may or may not have these features. But if you go into the history, you can see how many ampere hours you've done over a certain number of days and all this other stuff. I think it's kind of hit and miss on what it does save and doesn't save, but I think it's really, this particular controller is really geared for like an RV or something where you have it hooked up the whole time. But regardless, I found it kind of interesting. I'm kind of a stats nut as far as wanting to see, okay, last time I did this time I did that, and it was a cloudy day and we got this much. I was actually pretty impressed that even on relatively cloudy day, you got a pretty decent amount of charge. It's not the same, but it's still pretty good. When you're all done charging, you feel like you've got enough ampere hours into it, go ahead and disconnect the system. Be sure and disconnect it just like before. You connected the solar last. In this case, you disconnect the solar first. So disconnect the solar first, leave the battery on until last, and then remove the battery last. So I recommend doing a sample observing session or two at home, even if even if it's a cloudy night and you're just pointing your telescope back and forth and up and down and what have you, just to see, kind of how your usage is, and then practice, hooking it up during the day and charging it so you can act like you're out in the boonies, even though you're in your backyard. Sure as heck, you're going to find that there's something missing. If you look in the bottom right of my little plastic box there, you'll see a screwdriver jammed down there. One time I was hooking these guys up with alligator clips, but another time I wanted to hook up to a larger battery. Well, it had posts on top of it that had Phillips screws. So, if you came up short on screwdrivers, it would be bad news. Obviously it's an easy thing, but so it's good to practice. I went ahead and set up a battery box for me. This is kind of outside of the world of solar, but it's just a general usage thing. So in my case, I've got my mount battery and my computer and camera battery separate, and I've got little voltmeters and things on there, and little. I went ahead and chose a cigarette lighter connector. If I was doing this from scratch all over again, I would be using the Marine USB-C connectors. You can do a USB-C 12 volt with relative ease, and you don't have to worry about polarity and all this other stuff. I went ahead and put a cover on, built it so it has a cover, so if there's dew, you don't have to worry about your battery getting wet. It also helps you out in the winter, keeps the whole battery area kind of a little bit warmer than just setting a battery on the hard ground or on the snow or whatever. I also set it up so I have a jumper and a resistor. So if I want to kind of give a little bit of juice from one battery over to the other, there's always going to be one that's a little bit higher than the other. And you're right about time for the comet to come across the horizon, and you realize your battery's starting to get a little bit low. That's a nice feature to be able to have. That is my presentation. Any questions?
Hey, Jack, have you heard of Anderson power pole connectors?
That does ring a bell. They're polarity free? Is that correct?
Well, they are, yeah. They are red and black for your colors, and the wire's the same thing. So if you make those kind of connections to your battery, and then you make cables to go from the battery to all your equipment, it's real easy to disconnect and connect.
Okay. Yeah, I'll have to check that out. Anderson power pole.
Yeah, I got some pictures.
Right.
I'll show you a couple of pictures of those in a minute.
Okay.
But I got yeah, I've got questions. I've got questions.
Since I got questions.
I got questions. So you said you're in your car doing some work, right? It's nice
Right.
to sit in there with air conditioning.
Right.
As long as you're polluting the environment, you can hook up a battery charger to your batteries. So
Yeah, you got me there.
yeah, what do you mean you can't do that? Your car is going to be generating excess power anyway.
You got me dead to rights on that. That's absolutely true.
So you're not going to be producing any more car, considering the power that needs to charge the battery.
Yeah.
You're not adding any.
I just give that as an example. You don't have to be right there you could be in the shade, sipping a beer 20 feet away from your stuff and still checking out things there are.
I'm not all that, I mean, if it comes between running out of battery power at 2:00 in the morning because I thought I was saving the environment by not charging it off my car. It's cloudy during the day. Again, that was the other point was make sure that you have a battery charger that you can use from your car, because there's a lot of situations. Yeah, there's a lot of situations I ran into where it was cloudy during the day, but then it cleared up at night.
Right.
And I've got if you've looked at my websites, I'm big into the solar power stuff for astronomy. Right? Have you seen my stuff, Jack?
No, I gotta check that out.
Okay. Well, yeah, I can give you images, but it was all on the Google Sites before Google Sites took it down.
Oh.
So yeah, when you're talking about doing your power factors and loads and that, you're right on there. The one thing to do is when you're doing you're multiplying volts times amps, and so now you wind up with volt amps. Well, that's watts, and watts is really what you should be working with if you're mixing your voltages like 12 volts and 110 volt appliances. So what'll happen is you have a 100 watt CPAP machine, and then your astronomy equipment is drawing 30 watts off a 12 volt DC, right?
Right.
So that's 130 watts total for your system. You don't have to do any mucking around with converting 120 and 12 volts. And then because it's real easy after that to find out what you want to run your system for 4 hours, then that's 120 watt hours, 120 volt amps, 120 amp hours. To get the amp hours into a battery, you'll have to divide that. It's kind of easier to just work with watts.
Right. Okay. Yeah.
And then your solar, let me see. Yeah. Your solar is, I guess you're just putting a solar panel out there and let the sun walk across it.
Yeah. Well, that's a good point. The way I set it up, I tried to find a relatively open area, but we had a camper that, pretty quickly that thing would swing around and go into the shade. Oh, okay. Yeah. You can, right. If you want to travel along, then you can get a little bit better. It's actually kind of surprising. Even I saw guys that just laid the solar panels flat on the ground. And
yeah.
thought they would have gotten hardly anything on them, and they were pretty decent amount of juice into it. So
yeah. The thing is, when you do that, you have to overrate your solar panel if it's going to be static.
right.
Now, if you do like what I'm showing in the video, okay, that's how I was able. I had that, and that's how I charged my batteries throughout the day. And general, if it was, and it allowed me to get a smaller panel for the same power throughout the 8-hour day. And so you can reduce size and weight by if you make an adapter for your EQ mount. And I had one guy walk by. He was walking by. He looked at it. He took about 3 steps and he stopped. And he backed up and he looked at that. The battery is off on the bottom right. He looked at that and he goes, "You're not." I said, "Yeah, I am." So the panel was driving the EQ mount, and then was charging the battery, which so it was kind of like a, if you didn't really know it, it was a what they call that, an infinity. What's that?
Mobius?
Infinity loop.
No, it's like when you use a motor to drive a generator to drive the motor.
A recursion.
Regenerative.
No, it's physics won't let you do it, but it's there's a term for that. God, I can't remember what it was. But anyway, yeah. So you use a generator. So the motor turns the generator, which generates power, which the motor uses to turn the generator. So it's
yeah. So how much overhead was that, though? You're taking a slice out of the pie to keep the mount going.
Well, so that's a good question. So you're doing all your current. You're actually doing a good job with your load measurements. My EQ mount only draws a couple hundred milliamps.
Yeah. Oh, okay. That's fantastic.
Okay. And so the biggest draw for me when I was using that stuff was the laptops.
Oh, they're brutal.
Yeah. So in this case,
those guys.
In this case, the power I was using charging was more than offset by the fact that I was always getting 100% out of the solar panel.
Okay, good.
From morning to afternoon.
Very good.
So I think you've got an EQ mount, right?
I do.
Yeah, whip yourself up a little adapter. I mean, that doesn't cost much as far as, size and weight.
Yeah.
And then when you get out there during the day, fire that thing up in the morning and just let it run. And you'll find out that it'll probably be fully charged, way early in the day. But here's the thing. When you have overcast, like you can see the clouds in this one, or if you have light overcast, you can still get some chargeability out of a solar panel.
Mm-hmm.
And that comes to your efficiency. So if it's hazy and you're just on a dynamic large panel, it'll take longer.
Yeah.
And if you can track, you can get much more energy out of that for the time that it's up there. So if you've got broken clouds, when the clouds break, this thing's always pointing at the sun, so you're going to get the maximum amount of power through the breaks.
And I meant to mention there's amongst solar panels, there's several different flavors of solar panels. The ones you get at Harbor Freight are junk. They're very large and very inefficient.
Yeah.
So paying a little bit more for the higher quality does make a difference.
Yeah, and then when you track the sun, you get even more out of it.
Yeah.
And then when you're testing this during the day, when you're getting the stuff going, you do some measurements and you find out, holy crap, this thing's going to charge my stuff from a complete discharge to a complete charge in, say, an hour, 2 hours. And that lets you say, I got this big ass panel. If I say I want my system to charge completely in 4 hours, then I can downsize to a smaller panel, and that's just a reduction in weight and size.
Right, and that's some people are backpacking in to do their astronomy. So
yeah, well, they're not carrying in an EQ6 unless that's right.
Right, but I mean, you see my point.
So absolutely.
If you had a SeeStar and just you're doing a little bit smaller kind of a deal, then you might.
And a SeeStar. Steve Boerner is really good at making adapters because you could adapt this with a light panel. Okay, if you're backing in a light solar panel, then it would really behoove you to whip up a little adapter for your SeeStar so you can attach it to your SeeStar during the day. And let the SeeStar point that at the sun so that you can maximize the amount of charge time you can get out of that little backpack solar system.
Yeah.
That's
the
Though,
just
I'm gonna
as
say,
real
though,
quick,
if you're
third-
using an external battery pack for your SeeStar, it won't drain down your SeeStar, and all you have to do is change the battery, charge the battery pack.
Say that again.
Sure. If like Andy has an external battery pack, I've got an external battery
Yeah,
pack,
right.
like a Talent cell or something like that.
Yeah.
If you use one of those with your SeeStar, it'll drain that down and not the SeeStar. So all you have to worry about is charging the external thing.
Oh yeah, right. And so the thing is, that's what your little solar panel on the SeeStar is charging that external battery pack. And then whatever power the SeeStar needs, you just make sure that the charge power from the solar panel is enough to charge a battery and then supply a little bit of power to the SeeStar. But quite honestly, even if it was 50%, you're still getting more. You're still getting power into your battery. That's right. That's right. I remember I did this for a 4-day trip where I was going to have no access. So I sized my system and I said, I need this size solar panel to get me a full charge every day. If I use the system every night to its, and I said, no, if I get a slightly larger battery, then I won't use all the power in one night. I'll use a little bit of that power. And then if I have a smaller panel, then what I can do is I can top off the battery or put power into the battery during the day. And I wound up with a smaller system that at the end of 4 days, I would run out of power. Even though I was only going to be out for 3 nights, it would be out of power on the 4th night if I started it up. You see where I'm going, Jack? You don't have to fully recharge during every day.
Right.
You're gonna want to kind of look at that balance.
So that's what I did with my CPAP machine. I over allocated on the battery so that I could get more than 1 day on that.
That's right. So you're kind of looking at as time goes on, you get to the end, you want that intersection of out of power to occur right after the day you pack up to leave.
Right.
And so as opposed to keeping that power available line flat line straight across the board.
Right. And you don't know what the weather's going to be, so having a little bit of heaven is a good idea.
Exactly.
So,
and as far as charging goes,
day, hey, it's time to make hay, so get in there.
So, and you put in a good amount of margin and buffer, but generally what you have to figure is it takes 120% to recharge a battery. So if you got a 1 amp hour battery, it generally takes like 1.2 amp.
Right. I should have mentioned the percentage of efficiency there.
But you had a whole you had a whole bunch of margin in there. So I just let everybody know that if they don't use margin, then they've got to look at that charge rate. So
yeah. And that's where that kind of comes back to where testing is important too.
That's my last bullet point in uppercase, in red, capitalized, italicized. All right, now have you done any thoughts about degradation of life over the life? Because the solar panels don't put out as much. The batteries start to weaken. I'm not sure how heavily you want to use these batteries and for how long. But
right, I've not done the calculations, but I have heard that the solar panels get a little bit worse over time. One of the things we had that was noticeable in Colorado was the dust started piling up on the solar panel. I didn't see a drop in efficiency, but that is one of the things that they say I'm going to be getting solar on my house too, and they say that solar panel efficiency drops. Some of it's just dust and stuff accumulating up there, bird poop, what have you.
Yeah, so I'm glad you touched on it because I did that whole solar work about 15 years ago. And you're right. You're going to get the panels are going to get dirty. It's like the rovers and their dust issues.
Right.
The thing is, you're right there with the dust buildup. You can look at it. You can take a handkerchief and dust it off. That's no big deal. If you're going to get it on your house, Missouri is particularly dirty, very dirty. In fact, it's got some of the greasiest, grimiest the pollen from plants is like you got to have a really good grease cutting soap. If you when you wash your panels, when you wash the stuff up there on the roof, yeah, about every 2 years is a good idea to clean those things off. They get grimy.
Yeah,
and
I could see that would be the case. Yeah.
You should see the roof of my car. Let's see. And so yeah, and you did a good thing. You did hook up everything and put an amp meter on there, and you had one on the charger, the system thing. And really, what you want to do is you want to get an ammeter on the output of the battery, so that when you fire things up, you can actually like even just a volt ohm ammeter. You know what I mean?
Yeah.
It's
And
got
I did have that built into that battery box, but you probably couldn't see it.
because a lot of times those things are kind of inaccurate,
Right.
and when you
Put a real meter on it. Yeah, that's a good point.
and so there's you either do a real good job of very accurately measuring your power requirements, and then you build a system that just manages that. So now it's small, cheap, lightweight. Or you say, like kind of sort of like what you did. You do the numbers on the paper. You say, yeah, I'm going to give it a 100% power factor increase. So that's going to double my need. And then for margin, I'm going to double that. So now you calculate like a 1 amp hour battery becomes a 4 amp hour battery. You don't have to worry about any of the meters and stuff, because you're right. When it says fully charged versus 20% charge, that stuff, I never find that stuff useful. Because you have dynamic loads going on this thing. Those things are good for static loads where you're drawing like an amp steady state. But when you put an ammeter on there with a scope, you got these big swings in power as your steppers turn on and off. Your internal heater turns on and off. There's all sorts of things going on with these electronics. If you got a laptop, when that fan comes on,
right,
or when it starts using the GPU, I was surprised as hell to see the spikes in my power curve just from a cheap ass little laptop.
Right.
And so, that requires an integration kind of approach. And I said, screw that. I just looked at the peaks and said, okay, this thing's got a 1 amp peak, 20% of the time. All right, I'm going to say I got a 3/4 amp load on this thing 100% of the time.
Yeah. My laptop was over 2 amps when I was charging. And
right. I forgot about that. Yeah. And you got to consider that when the laptop decides it wants to start charging its ass.
Right.
It wants to draw 2 amps out of a 1 amp hour battery. You're kind of like, uh-oh.
That's one thing I meant to mention on my battery box is I had a fuse built into that as well. So the fusing is a good thing. Your chances of sorting things out is, when you got wires everywhere and everything like that, it does happen, even if you're careful. So absolutely. There's an image where I just a small panel, for a couple of days kind of thing. I'm gonna look for those power. Anyway, so go ahead. I didn't mean to interrupt. No, I was just gonna say bring spare fuses too. Yeah.
Our chewing gum wrappers.
Gum wrappers.
Where is my? I'm gonna stop that. I gotta find my power pole.
Well, while you're doing that, Jeff, something else you could do. I noticed you had just 2 fold-out panels. Now, if you can have some way you can roughly control the angle. I mean, this is all thought experiment. Roughly control the angle, which is leaning it up against the ball or some sort of braces or whatever. So you got if the power you get on from the angle on a solar panel is just simply cosine related. 15 degrees, you get 96% of what you would get from straight on. So if every hour you could go out and just make an adjustment on there, that kind of gets you the sort of thought about how often you might have to go out and just make a manual adjustment to keep your charging as high as possible. So, you do it every hour and a half, you're still getting maybe every 2 hours, you're still going to get 20. You're still going to get, all short of maybe just losing 10% of what you could have gone if you had it dead on. So
Yeah.
You know, just find a big old find a beanbag.
Wait. Well,
chair or
yeah, that's
something.
there. You can improve on the beanbag by just a little bit, Andy, and
Yeah.
that's a stick. And then these little shadow type
Yeah.
solar fun sun finders, Jack.
Oh yeah, yeah.
Yeah, you
Yeah, you
put
can
that
do
on
that.
there, and then you just bling bling bling.
Heck, you could even put on your watt meter there and do some angle measurements and come back and tell us whenever, hey, I can go 3 hours without having to really worry too much about it because I'm only
Yeah.
losing,
Yeah,
if you got a big enough solar panel to, put out, all those, what Grant was talking about, you're maybe 1.2 better than what you
right.
need,
This
to
panel
get that.
actually had a little prop it up kind of thing in the back of it. But that's
Yeah.
a good point. Not all panels do, and it actually was kind of fun to me because for doing the astronomy a weekend or a week, it gave me something to do during the day. Obviously, you need to sleep in a little bit, or else you're not going to be able to stay up till whatever hours. But
Yeah.
it is kind of fun to just kind of, hey, what's it doing now? So like you say, repointing here and there is probably a good idea, and obviously you get a diminishing return to a point, but you certainly can get a lot more if you get it just straight on. And of course, at sunset you're not going to get as much either, even if you have it pointed the right way. But yeah, Sunfinder, you could stick a little stick on top of it, a little pointed thing with a target or whatever, and make sure you're perpendicular just perfectly.
You'll find that what happens is you drop off to the 90% point after about 45 minutes.
Okay.
So every half hour, I mean, that's the manual way. I mean, if you're going all the way out there with an equatorial head, you just mount it up, point it, and you're done for the day. But
Yeah.
as Andy says, if you
I
do it manually,
my solar panel, and maybe that's just it, because of my being a conservative estimating, but my solar panels were too big to stick on my mount. So, but I like what you did there, Grant. So,
what mount do you have?
I got the AM5N, but the panels are pretty wide,
Hey, Jack, you going to fall in that black hole for astrophotography?
Oh, I'm
It's
already too late now. I'm already going to the meetings, to the Astrophotography Anonymous meetings.
Oh, yeah. Oh, I hate this.
Yeah, it sucks.
I'm talking about this stupid thing here. I knew where those things were at, but this stupid Google site, man, they went from really good to just a POS.
We're taking all your stuff down, huh?
Well, it was well formatted and the images were right there. And then when it did the quote conversion, it lost a lot of images, and then there's a lot of formatted stuff that it didn't incorporate because it wasn't supporting that kind of layout. And so my site's sad. I think Steve went through this. Steve had a really good site. But I just saw those. I wonder if that was over there.
Any other questions on the presentation?
I guess you could.
Thank you, Jack.
Yes.
You're certainly welcome.
Jack, that was interesting. Thank you.
There you go. I found him.
Huh.
I found him. Where's that share site at? There we go. Share. There we go. And right there.
I'd appreciate, I would add your slides to the newsletter if you send me a link to the presentation.
Okay.
You see those, Jack?
Connectors. Oh, that's the ones
Those are the power poles. So, it's polarized, absolutely. And then they're a click friction fit. They're quick disconnects, so you can pull them apart, easily put them together. But the classic cigarette lighter adapter that has that spring-loaded tip,
right,
that eventually pushes itself out in the middle of a photo run.
right.
That's right.
It's not the way to go.
No. So these need a crimper, but they are, Andy, like as Andy says, these things are the cat's meow. So
Yeah.
that's what we're talking about. And
Thank
Stop.
Speaking of cats meow, where's your cat?
Shush! Man, dude.
I think he found it.
I gave him 3 kitty cat treats, which is generally 2-hour nap time. I drugged him.